Okay, hi again everyone. It's Professor Sebastian back with our Calc 3 class notes. We are on page 33, working up towards example 31. So speed on a smooth curve. Since the arc length parameter is given by this definition, which is the integral from t naught to t of the speed, d tau, right? Where I put in tau as a dummy variable to integrate. The fundamental theorem of calculus tells us that if I take the derivative of s, the arc length, with respect to t, then we know from the first fundamental theorem of calculus, I forget if it's part 1 or 2, it doesn't really matter, but if I take the derivative of this integral, then I just get v of t, the magnitude of v of t, which is speed. So ds dt is another notation, but it just means speed, which says that the speed with which a particle moves along its path is the magnitude of velocity, which is consistent with what we already know. Okay, the unit tangent vector is an important vector that we'll work with over the rest of the semester. So we already know that v, the velocity vector, is the derivative of the position vector dr dt. That is tangent to the curve r of t at the point t. Thus, the vector capital T equal to the direction of r, right, which is v over the magnitude of v. This is the unit vector tangent to the smooth curve. That's called the unit tangent vector. So velocity is dr dt, the first derivative of position. So if I take that velocity vector and divide it by its magnitude, which is speed, the bottom line is that is a unit tangent vector, rather than just looking at r prime of t, the velocity vector itself. For example, let's compute that. So find the unit tangent vector of the curve representing a different flight path for a hang glider. So this is a different flight path. R of t is 1 plus 3 cosine of t in the I direction, plus 3 sine of t in the j direction, plus t squared in the k direction. So if I want to find the unit tangent vector, I first find the velocity vector, which is r prime of t. So that's just the derivative of 1 is 0, derivative of 3 cosine of t is minus 3 sine of t in the I direction. Derivative of 3 sine of t is 3 cosine of t in the j direction. Derivative of t squared is 2t in the k direction. So if I want to find the magnitude of that, square each component. Take the square root of their sum. So you get 9 squared t plus 9 cosine squared t. 9 times sine squared t plus 9 cosine squared t plus 4t squared. So in these first two terms, I can factor out a 9. I have 9 times sine squared of t plus cosine squared of t, which is Pythagorean identity is 1. So I end up with 9 plus 4t squared under the square root. So the unit tangent vector then is the velocity divided by its magnitude. So minus 3 sine of t divided by the square root of 9 plus 4t squared in the I direction, etc.